Hi everyone. Today we're talking about lesson 4-3 in Algebra 1. Today we're going to be talking about zero exponents, negative exponents, and fractional exponents. So these are kind of three areas when we're talking about exponents are kind of three little odd things that come up we need to look at and know what they mean. They're not as intuitive as you might think. So we'll talk about these three things. Our central question is what do these things represent? Okay, so we have looked at the quotient of powers property, and that just simply says if I'm dividing, right, and dividing expressions with exponents, they have the same base. I can simply subtract the exponents, right? And we've looked at some examples of that. For example, um, if we did, x to the fourth over x squared, we would get x to the 4 minus 2 power, right? You subtract those exponents, would just be x squared. We've looked at some other examples of how to reason through that, and x is canceling out and so forth. So what happens when we have an expression like this? So we have 4 to the second power, 4 to the second power. Well, we already know that when we divide a number by itself, it's always equal to 1. And so and we've looked at how to, like, if this was 4 times 4 divided by 4 times 4, right? This 4 would cancel this 4, that would make a 1. This 4 would cancel this 4, that would make a 1. I'd end up with 1. But if I look at this from the point of view of the quotient of powers and I subtract, I could also say, well, this is 4 to the 2 minus 2 power. And 2 minus 2 is 0, so we would say this is 4 to the 0 power. And we already know that it's equal to 1, so we would know that 4 to the 0 power is equal to 1. And that's actually the definition of the 0 power. Anything to a 0 power is going to be equal to 1. Likewise, if I have x divided by x, this is x to the first over x to the first. This will be x to the 1 minus 1 power. This would be x to the 0 power. And x to the 0 power is just simply 1. Notice there's no variable in this now. Once it goes to the 0 power, it turns into 1 only. It's not 1x. It's just 1. Okay, so we talked about 0 power and 0 power. What happens if we have a situation like this? Now we've looked at division and canceling, and we said, well, this is x. This is x over x, or sorry, x times x divided by x times x times x. And again, we saw we could cancel these. This would make a 1. This would make a 1. And I would be left with 1 over x. So we could say 1 over x to the first. Again, if I look at my my quotient of powers, I could say, well, this is x to the second minus the third, x to the 2 minus 3 power. I could subtract these exponents. And in this case, I would get x to the negative 1 power. And I already know that this is equal to 1 over x. So this negative power actually just moves that variable down into the bottom part of the fraction, right? It moves it to the other side of the fraction bar, and it becomes positive. So 1 over x to the first is the same as x to the negative first power. So that's the first two of our rules today. So we're going to look at the 0 power. So anything raised to a 0 power is 1. So if I have a to the 0 power, that would just be 1. If I had 3 times x to the 0 power, well, the only thing that's being raised to the 0 power is the x. So this would be 3 times 1, which would just be 3. If I had 3x in parentheses to the 0 power, well, then everything in here would get this 0 power. So this would be 3 to the 0 power times x to the 0 power, which would be 1 times 1, which would just be 1. Okay, so anything raised to the 0 power is going to be 1. And then the second thing we talked about is negative exponents. So negative exponent just means that that exponent is on the wrong side of the fraction bar. So if I have x to the negative 2 power, I would say, well, that's x to the negative 2 power over 1, right? I think of that as a fraction. And what that means is that this negative 2, this x to the negative 2 power, should actually go in the denominator and become positive. So that's the same as 1 over x to the second power. And likewise, if I have a negative exponent in the denominator, it means that that should actually move up to the top into the numerator of that fraction. And so this would be 1 over x to the negative 2 power would be x to the second power would go to the top of that, and we just have a 1 on the bottom. So this would just be x to the second power. Okay, so whenever we see that negative exponent, it just means we're gonna flip that fraction over. We're gonna turn that variable into a fraction and just flip it over and make that exponent positive. Okay, let's take a look at some examples of this. So here we have y to the negative 3 power. So this is the same as 1 over y to the third power. Okay. I would turn this into a fraction, and I would just flip that fraction over. On the second example, we have 2m n to the negative 2 power. So the only thing that's being raised to the negative 2 power is the n. And so this would be 2m times 1 over n squared. And if I turned all these into fractions and multiplied straight across, I'd have 2m over n squared. Okay, so this n to the negative 2 power simply moves down to the bottom to the denominator of the fraction. It's in the numerator here, and it moves down to the bottom and becomes positive. In this example, we've got a couple of things that are in the wrong spots here. I've got a y to the negative 2, so that needs to move up to the top, and I have an x to the negative 1, that needs to move down to the bottom. The 3 and the 4 and the x in the denominator don't have negative exponents. They all have an exponent of 1, so they're just going to stay right where they're at. So I'd have 3, and then this y to the negative 2 power is going to move up to the top. This is going to become y to the positive 2 in the numerator. And then in the denominator, I have a 4, and I have an x, and then this x comes down to join it. So this x moves down to the denominator and becomes x here. So this is 3y squared over x squared. Sorry, 4x squared. All right, let's look at a couple more examples here. Here I've got a 0 exponent. I know that this is 1. Y to the 0 is just simply 1. And anything multiplied by 1 is just itself. So I can, in theory, right, in practice, I can actually just ignore that. This is just a 1. And so I'm left with 2 times x to the negative 4th. Well, that negative 4th means that x has to go down to the numerator, to the denominator. So we're just left with 2 times x to the 4th power. And this is just a 1. So it's times 1, which is 2 over x to the 4th. And then our last example, we've got this very complicated thing here. So we've got 3 x to the second power, y to the 5th power, z to the negative 7th power. Now we could go through and move this z to the 7th power down to the denominator and change all that around. But I see right here that all of this is to the 0 power. So this is 3 to the 0 power times x to the 0 power times y to the 0 power times z to the 0 power. This is 1 times 1 times 1 times 1. This is 1. Right? Anything to the 0 power is 1. Okay, and then the very last thing we'll touch upon, and we'll get more into this probably later, but we want to talk about fractional exponents. So when you see a fraction as an exponent, that simply represents the root. Okay, it represents the root of a number. And so, if I have x to the 1/2 power, that actually means the square root. And most of the time when we have a square root, we don't write the 2 there, but it's implied. There's a square root there. Okay. This means that this multiplied by itself would give us x. And I can see that if I say x to the 1/2 times x to the 1/2. Well, when I multiply these things, they have the same base, and so I add the exponent. So this is just x to the first power, or x. Okay. So this 1/2 represents, right, the square root, the number that I would multiply by itself to get x. So in this example over here, I have 9 to the 1/2 power. That represents the square root of 9, and the square root of 9 is 3. Now, when we see this, right, we're talking about the positive square root. If we were talking about the negative square root, we would put a negative in front of it, or in parentheses, right, put a negative in front of it. That would give us the negative square root. But right now, this is only talking about the positive square root. Likewise, when we have a fraction with a different denominator, it just represents that root. So this is x to the 1/3 power. This is the third root, or the cubed root of x. Okay, so this would mean I would multiply this cube root of x together 3 times in order to get x. So it'd be a number that I multiply together 3 times to get x. So this would just simply be the cube root of x. And likewise over here, this would be 8 to the 1/3 power is the cube root, right, the third root of 8. And so I know that 2 to the third is equal to 8. So 2 multiplied together 3 times is 8. So I know that the cube root of 8 is 2. 2 multiplied together 3 times gives me 8. And then sometimes you'll see these with a numerator on here. What this numerator means is just simply the power of the thing under the radical sign. So this is the radical sign here. Underneath that root sign, that's the power of that. Okay, so this would mean the fourth root of x raised to the 5th power. So x to the 5th power. And so I could actually say that this is the fourth root of x to the 4th times the fourth root of x. This is x to the 4th. This is x to the 1. Right? X to the 4/4, x to the 1/4. So for x to the 4/4, this gives me x. So the fourth root of x to the 4th is just simply x. And then I'd have the fourth root times the fourth root of x. So that's how I would simplify that. Okay. We're not going to spend a whole lot of time simplifying them, but we do want to realize that what this number on the top, the numerator of this fraction represents, is the exponent underneath that root, underneath that radical sign. And the denominator represents the root of that number, right? The fourth root, or the third root, or the second root, right? The square root, the cube root, the fourth root, etc. Let's look at a couple of examples here. So here I've got a power, right? An exponent expression raised to a negative fraction, right? A negative fraction. Okay, so when I multiply these, right? When I take this to the 1/3 power, we multiply these powers together, right? If I have a power raised to another power, right? It's c to the third to the negative 1/3 power. So I would multiply those together. So I would get c to the negative 1. Sorry, let's try that again. Let's do this. This negative 1/3 power here, right? Let's do the negative part of this first. So this negative part of it just simply means to flip it over. So this just means 1 over c cubed d to the 4th. And all of that is raised to the 1/3 power. So we moved this down to the denominator, right, and made it positive. So this is just simply going to be 1 over c, and we're going to multiply these together. This is c to the 3/3, right? So 3 times 1/3 is 3/3. D to the 1/12. D to the 1/12. So again, let's try that again. C to the 3/3. And this is 4 times 1/3. 4 times 1/3, that's going to be 4/3. D to the 4/3 power. So that's how we would write that. And if we wanted to simplify that, we could simplify that c to the 3/3 would just simply be 3. So this would be 1 over c. 3 to the 3/3, that's 1. C to the first is going to be 1. And d to the 4/3, well, 4/3 is 1 and 1/3. So this is going to be d, right? And d to the 1/3. So it'd be d root d. That would be another way to write it. But for right now, this way is perfectly acceptable. For this example here, we are multiplying two numbers that have the same base. And so we're just going to add those exponents together. So this is x to the 2/3 plus 3/2 power. Okay, so they have the same base. We were multiplying them together, so we add those bases together. And so what we have to do then is just figure out what is 2/3 plus 3/2. So if I look over here, I want a common denominator. That common denominator is going to be 6. So I'm going to multiply this by 2 on top and bottom. I'm going to multiply this by 3 on top and bottom to get those denominators the same. And so I have 4 over 6 plus 9 over 6. And so I have 13 over 6. So my answer would be x to the 13/6. And then the last one here, here we have a power raised to another power. So when we do this, we multiply these together, right? This is y to the 2/5 to the 3/5 power, right? So it's y to the 2/5 multiplied together 3/5 times. So we're going to multiply these. So this is y to the 2/5 times 3/5. And 2/5 times 3/5, we just multiply straight across. This is y to the 6 over 25. Okay, we're not going to do a whole lot with these fractional exponents currently, but that's how they work. And so when we see them, like that's how we'll evaluate them. Okay? It just represents a fraction. So if I wanted to write this as a radical, this would be the 25th root, right, of y to the 6th. Likewise, this would be the 6th root of x to the 13th. Okay, I'm going to go ahead and end it there. So take a look at the assignment and let me know if you have any questions.